Hello students, welcome to Legacy IAS Academy. Today we are going to discuss another very important concept in the physical geography, especially geomorphology section, that is about the continental drift theory. Now if we talk about continental drift theory, it is one of the most important and significant theory because this is also the first theory that has been given which explains about the movement of the earth's surface or movement of the earth's crust and the causes of such movement, and also what is the impact of such movements across different parts of the earth. So if we try to understand this theory, the continental drift theory was given somewhere in year 1912 for the first time by a German geologist who was called as Alfred Wegener. So Alfred Wegener, he became very interested to understand the movement of the earth's surface because he found certain evidences that suggested that earth's surface is not static, earth's surface is not steady, rather it keep drifting from one place to other place throughout the historical time. And thus finally, after working for few years, in the year 1915 he published his theory, all the points of his theory in a journal. However, when he published his theory in journal in 1915, his theory was largely rejected. The reason behind that was very simple, because at that time prevailing view across the scientific community was what we can call as contractionist view. Contractionist view means that time many geologists, geographers and scientists believe that earth has been continuously cooling since its time of formation, and if earth is continuously cooling, that means it is shrinking, and its shrinking is what result into formation of different landforms, be it plateaus, be it mountains or any other kind of landform. On the other hand, the continental drift theory of Wegener was trying to change this viewpoint. He was more of what we can say expansionist, because he believed that it is the expansion of the continental crust is happening, and that is what is leading to development of the landforms such as the fold mountains, and that is why his theory was largely rejected. It is only after 25-30 years, somewhere in the 1950s and 1960s, when more detailed study of the ocean floor was conducted, it was found out that what Alfred Wegener has said, largely it can be proved, and thus his theory started to gain credence, and finally many of the concept he gave in his continental theory also form the basis of the another theory that we have discussed yesterday, that is the plate tectonics theory. Thus what we can say, in one way it is the continental drift theory of Wegener that has inspired or that has provided the basic ideas behind the plate tectonic theory, which is widely accepted theory today. So let us try to understand what is the continental drift theory all about and what Wegener was trying to explain by this particular theory. Now, before giving his theory, Wegener has made certain assumptions. As we know, this is the case in all the theories. So what are the assumptions Wegener has made? So first assumption he made was, he was working on the model of the earth that was given earlier by Edward Suez. And Edward Suez has said that the earth's crust is made up of Sial, that is, Sial is the short form of two elements, we have silica and aluminium. So earth's crust is made up of Sial, and then the second layer, the layer below earth's crust, that is Sial layer, we have the second layer. The second layer is what we call, or what he called as Sima layer. So basically what Wegener tried to say, Wegener said that the continents of the earth, these are made up of Sial. We have total 7 continents today. So Wegener was saying that the continental land masses on the earth are made up of Sial, and these Sial land masses are freely floating over the Sima layer. So if we talk about this, this is our Sima layer. Now Sima stands for silica and magnesium, because we have a dominance of silica and magnesium as per Edward Suez in the second layer. So first assumption that Wegener made is that continental crust is made up of Sial, and this Sial is freely floating over the Sima layer. And what happens, sometime a gap is created between two Sial layers, and this gap is then filled up by water, and this is what leads to development of the ocean body. So we have Sial floating over Sima, and in between two seals we have the water that is stored, water that is occupying this region, that has led to development of the ocean masses. Then the second assumption he made is that CMA does not offer any resistance to Sial. This he will change in the later part or later stages, but in the beginning when he was making the assumption, he explained that the CMA layer, the second layer, the middle layer of the earth does not offer any resistance, to Sial layer. That means what he is basically trying to say, that as Sial moves over Sima, it moves freely without any kind of resistance, same way how boat moves over a river. Similarly, the Sial is freely floating over the Sima layer. So this is the second and most important assumption that Alfred Wegener has stated in his continental drift theory. Now, what the continental drift theory is all about? Wegener basically was trying to explain that the continental land masses on the earth, they are not static, they are not fixed at any particular place. Over a millions and millions of years from the past, they have been continuously moving across at different rate, and thus he explained this entire process for last 250 million years. And thus the first part of his theory basically we try to understand about is that if you look at the earth that has formed, earth that is about 240 million years ago. So if you look at the structure of earth as per Wegener, 240 million years ago, that time he says that entire earth is basically covered by a single supercontinent. That means all the land masses on the earth, they are joined together. All the land masses on the earth are joined together to form a single landmass, and this single landmass, which is called as supercontinent, was referred as Pangaea. So we have Pangaea, and thus obviously what will happen if we have a single supercontinent, single landmass, that means this entire landmass is also surrounded by a single water body, which we can refer as ocean or super ocean, and the super ocean is what we call as Panthalassa. So that is the first point of his theory, that 240 million years back, if you go and look at the structure, geological structure of the earth's surface, we have a single continental landmass Pangaea, and we have a single water body that is surrounding this landmass, which we can call as Panthalassa. However, what happened as time passed, somewhere about 200 million years ago, somewhere we can say 200 million years ago, this landmass Pangaea started to break apart into two different landmasses, and thus gradually we are seeing a splitting began. Splitting began in Pangaea, and by the end of 180 million years, splitting began when? About 200 million years ago, and by the end of 180 million years ago, what basically happened is that the Pangaea split apart into two different continental landmasses. One we can say is what we can call as the northern landmass, while other became what we can refer as the southern landmass. And obviously what will happen, as the landmass split apart, the area between these two land masses got filled up by water, because the water from the nearby oceanic area, super oceanic area that we have discussed surrounding this Pangaea, it has started to fill this gap again, and thus we have formation of a narrow sea-like structure in between these two land masses. This northern land mass then is what is generally referred by the name of Laurasia, and this southern land mass, this is what we generally referred as Gondwana land. Now, why it is referred as Gondwana land? That is also a very interesting point, because he referred it as a Gondwana land because in this Gondwana land you have modern day India, and in the central part of India we have the tribe that is called as Gond tribe that resides here. So basically he referred this as a land that is occupied by an ancient tribe, that is the Gond tribe. So that is why we have Gondwana land. Now, once the splitting happened, as we have discussed, the water will fill up this gap, and thus we have formation of a narrow and shallow sea. This sea is what we refer as Tethys Sea. Thus what we can understand, that since 240 million years ago, till 180 million years ago from now, the entire continent split apart into two different land masses, Laurasia in the north, Gondwana land in the south, and also we have a shallow sea that developed, which we call as Tethys Sea. Now gradually as time passed, again we see splitting of these two land masses as well at different places. Thus, what we can say happened, if we go further, we have Laurasia in the north. So Laurasia is basically splitting apart into three continental land masses. One is what we today call as North American continent, that today consists of USA, Canada. Then one other small land mass also broke apart from Laurasia, which is referred as Greenland today. And the biggest land mass that was part of Laurasia is what we can today call it as a Eurasian landmass. In geopolitical term, Eurasian landmass consists of two continents today, Europe in the west and Asia in the east. Thus, Laurasia is split apart into three continental landmasses, Eurasian landmass, Greenland and the North American landmass. On the other hand, if you look at the Gondwana land also split apart to various different landmasses. For example, one part split it apart, and then this is what today we call as South American continent. Other part is what we can refer as African continent. Then in the southern side we have the Antarctican landmass. Then next we have obviously the Indian landmass. That time the landmass, the area of the Indian landmass, Indian plate was much more bigger than today's India, because a large area of India's plate, Indian crust has basically got destroyed due to its collision with the Eurasian landmass in the somewhere about 30-40 million years ago from now that has begun. Then one other part that broke away from here is what we can refer as Australia. Here we have a small island that broke away from Africa, and later from India. This island is what we can refer as Madagascar. So we have Madagascar, and attached with Africa was another landmass that we can call as a minor plate, that is the Arabian plate. So basically Gondwana land has splitted into South America, Africa, Arabian plate, Arabian landmass, Madagascar, India, Australia and Antarctica. So this is how we are having the splitting of both Laurasia and Gondwana land. Now once this splitting happened, somewhere splitting has been going on since last between 180 million years to 100 million years, and after that these land masses, after splitting, it's not that just stopped somewhere. After splitting, each of these individual land masses have been continuously moving in different directions, and that is why what happened gradually, if we try to understand, due to their continuous movement in different directions, finally they occupy today different places, and that has given what we can say our world map today. So if we try to understand how these land masses are arranged together, so we have North America here and South America. As you can see, South America has moved slightly to the west and North America has moved slightly to the south, slightly to the west and to the south, and thus today North America and South America are joined together like this. Greenland is separate here somewhere near Arctic, and then we have the Eurasian landmass that is here like this, stretching all the way from Siberia in the Russia to like this. And then here what has happened, African plate has also moved, African landmass also has moved to the north, and now it has collided with the Eurasian landmass, and it is also connected to the Arabian landmass. And further if you go to the east, we have the Indian landmass that has collided with the Eurasian plate. So India is attached to Eurasia now, and then we have this Southeast Asia, and then we have some islands here, and Australia has drifted further to the east and it occupies this region, and Antarctica obviously is near the polar areas, south polar areas. So that has given rise to our present configuration of the world. Madagascar is somewhere around this region, and thus from a single supercontinent Pangaea and single super ocean Panthalassa, what do we have today? We have total 7 different continents and 4 different oceans. If talk about continental landmass, this we can combine together. So we have Eurasia, we have Africa, North America, South America, Australia, Antarctica, and in between we have the oceans, such as in the upper part we have the Arctic. Then in between the North America, Eurasia, Africa and South America, we have the other ocean that we refer as Atlantic Ocean. Here between the North America, South America and the Eurasian landmass, we have the largest ocean, the biggest ocean of the world, that is the Pacific Ocean. And here to the south of India, we have the Indian Ocean, and around surrounding the entire Antarctic landmass, we have the fifth ocean that we can call as the Southern Oceans as well. So total 5 oceans we can say has developed, and 7 different continental landmass from the single landmass of Pangaea and single super ocean of the Panthalassa. So this is how Wegener has described that the Earth's continental crust has continuously moved in last 240 million years, and before that also it has been continuously moving. Because if I ask you what is the age of the Earth, age of the Earth is somewhere about 4,500 million years. But Wegener had just explained that how the continents have moved, how the Earth crust has moved in only last 240 million years. That may before that also what has been going on. There must have been some kind of movement must be going on there, and that is why today scientists believe that there is a continuous splitting of the single landmass. Then again, since Earth's area is fixed, these land masses come together, join together to form a single landmass. So continuous splitting of a single landmass, and again they are merging or merger into to form a single landmass. That has been going on for many times. That has happened in a kind of cycle in many times in the Earth's past history as well. However, Wegener's continental theory explains only about last 240 million years. So when Wegener explained about all this, first of all, when he presented this data, his evidences, many of his peers asked that what is the evidences to support your theory. So Wegener obviously he just not described everything theoretically, he also has given a lot of evidences to support that indeed this continental drift, indeed this change in the configuration of the Earth's continental crust has happened. So next what we can try to understand that what are the major evidences that Wegener has gave to support his theory. So we can write evidences to support continental drift theory. So here what Wegener said, first evidence, which is the most important evidence he gave, is that if you look at the coastline of Africa, if you look at the continent of Africa today, its coastline is something like this, and similarly if you look at the coastline of South America, it is something like this. So what he did, he said that if the continental drift indeed had happened, that means the coastal configuration of the African continental landmass and South American continental landmass should match each other, because both have basically broken from the same piece of land. So actually if you try to bring these two land masses together, Wegener actually later also the study was conducted somewhere 6,000 feet below the sea level, when the coastal configuration of African coast and South American coast was done, it was found to be perfectly matching with each other. Actually what will happen, if you look at this part of South America and if you look at this part of Africa, if you bring them together, try to imagine it, and if you bring them together, what happens, this part is completely basically what we can say, this part is completely overlapping with each other. So this coastal configuration and this coastal configuration is same. Similarly, other matching that also we see in the case of Madagascar and in the case of India as well. So Madagascar, India and South America and Africa, the coastal matching of these continents explain that indeed all these land masses were part of a single landmass as given by the continental drift theory. So this is the first evidence. This many times is also referred as jigsaw fitting evidence. The name of this evidence is jigsaw fitting, because jigsaw is what? It is a kind of puzzle where you have lot of puzzle pieces. When you try to bring all these puzzle pieces together and try to arrange them as per their structure, they form a single unified structure and some sort of meaningful shape or pictures you will see. So similarly, if you bring all the continental land masses of the earth together, what will happen? You will see a formation of a large structure that he referred as Pangaea. So jigsaw fitting evidence. Then after that, the second evidence what he gave was in terms of the rock. In terms of rock, what he found that there is a special type of rock which are called as tillite rock. So tillite rocks are basically found in several continents such as South America, such as Africa, and even in India. So what is unique about this rock? Now the problem is that if you look at these three continents, South America, Africa, India, what we see that these continental land masses are today lying in a tropical zone. So if they are lying in the tropical zone, that means their temperature is, average temperature is higher. There is no glacier anywhere in these areas except the Himalayas of India. Anywhere in the tropical zone of India, Africa and South America, we do not have any glaciers because temperature is never below 0 degrees Celsius. But the problem is that these rocks, if you look at the structure of these rocks, if we try to understand how these rocks are formed, these rocks can only develop due to the glacial movement. The tillite rocks generally are believed to develop due to the movement of large scale glaciers over the rock structure, over the crust of the earth. Thus, how come these rocks are found in these continents where we do not have any evidences of glacier? And thus Wegener explained that if you go back and you try to understand what Wegener has said, that all these three land masses are basically part of what? They are part of Gondwana land. And what else is the part of Gondwana land? It is the Antarctica landmass that is part of Gondwana land. Thus he says that when South America, Africa and India, they were joined together to Antarctica, we know that Antarctica is one of the largest source of glacier on the earth. So basically he said that what is happening, the ice sheets, the glaciers from Antarctica are kind of moving in the northern direction, are flowing in the northern direction, and during that time they are covering the land masses of South America, Africa and India. Thus this glacial movement is what has led to development of this tillite rock. Now once these land masses splitted away from Antarctica and started to move in the tropical areas, what will happen? Whatever glacier is left, whatever glacial land masses is left on South America, Africa and India, what will happen to it? These glaciers will start to melt, and as these glaciers start to melt, the water will remain only there and rock will only remain. Water will gradually maybe convert into rivers or just simply evaporate away. Thus the evidences of glacier will simply vanish, while the rock, the tillite rock that has formed due to the movement of glacier, that will remain wherever it is. Thus he said that this also proves that indeed continental drift must have happened, because this is the only explanation of such kind of evidences, what we can call as the rock evidences. So this is the second most important evidence that was given by Wegener in support of continental drift theory. Now the third evidence is, we have discussed that North America and Eurasia, these were part of a single landmass, that is Laurentian landmass, and a splitting has happened between the Laurentian landmass and the North American landmass. Thus if we try to draw the map here, if you look at the North America, so if you look at this part of North America, that is on the northeastern coast of US and Canada, we have a mountain. This mountain is what we refer as Appalachian Mountain. Similarly, if you go to the northwestern Europe, you have, in Great Britain is there. In Great Britain you have a Scotland, and in Scotland also we have a mountain that formed during Caledonian era. So that is why it is called as Caledonian Mountain. Further in Europe you have Scandinavia, so we have mountains in Scandinavia as well. Some mountains are there, mountain like structure in the Greenland as well. So basically when he compared the Appalachian Mountain of North America and the Caledonian Mountain of Scotland in the British Isle, as well as the Scandinavian mountains of the Scandinavian region in northwestern Europe, what he found? He found striking similarities between the rock structure, the age of the rock, as well as the overall composition of the rock. That means he then said, he tried to explain that all these mountains which today are located far away from each other, because basically between this Appalachian Mountain, Caledonian Mountain, what do we have? We have a vast Atlantic Ocean. So he said that the striking similarities between these mountains can only be explained by the fact that at some point of time in the Earth's history, these land masses were basically joined together, and thus these three mountains that we see today separated apart must be part of a single mountain chain. That means if you try to imagine and bring all these land masses together, what will happen? These mountain will again join together to form a single mountain chain, and that is why they are very similar to each other. But due to continental drift, what happened? The land masses splitted apart, they moved away from each other, and thus these mountains broke away into 3-4 different segments, 3-4 different parts. So that also is another important evidences which we can write as mountain similarities that exist between the mountains of North America as well as the northwestern Europe. The other very important evidence what we can understand is that if you look at the rock or minerals, what you can say minerals of Africa and South America, basically there is a deposit in Africa, mineral deposit in Africa that are called as placer deposits. Placer deposits largely is seen either for gold or for diamond in case of Africa. Now what is placer deposit? So placer deposit simply means that, for example, somewhere you have a large rock structure is there. In this rock structure, what do we have? We have different kind of minerals can be there. For example, in this rock structure here and there, what do we have? We have, suppose, gold is embedded. So what happens if suppose a river is flowing over this rock? What will river do? River will cause erosion of these rocks, and as river causes erosion of these rocks, what happen? The gold particles, the gold minerals that are embedded in these rock structure, they start to flow along with these rivers, and then they are deposited somewhere in the lower part of the river or the river bed in the lower part of the river, and thus these mineral deposits which are found in the river bed or along the river in the sedimented form or sediment form is what we can call as the placer deposits. That means if we can find placer deposits of any mineral anywhere, what we can understand that it must have sources somewhere far away from this particular region, and that is exactly what we see in the case of South Africa and this South America, because what is happening, sorry, it's not South Africa, it is the equatorial Africa. So that is what exactly we see between the equatorial Africa and the South America. In equatorial Africa, you have a country that is called as Ghana, and in South America, you have a country on the eastern coast, one of the largest country, that is called as Brazil. So basically, if you look at the placer deposits of gold, the placer deposits of gold are found in Ghana, while the source region of the same gold are found in the Brazil. Now how is this possible? Because today Brazil and Ghana are separated away by a vast Atlantic Ocean, thousands and thousands of kilometers of Atlantic Ocean is there. Thus the only way how we can explain that there is such a huge distance between the placer deposits and the source is by understanding that at some point of time the South America and African land masses were joined together, and this river was flowing from South America to Africa. They deposit a lot of placer deposits in Africa, but gradually due to continental drift, what has happened? The splitting has happened, and thus the source of minerals went away from this what you can say African land masses to Brazil, while the placer deposits remained in the zone of Ghana. So that is how we can explain the formation of these placer deposits as well as the source material, which also serve as a very strong evidences in support of continental drift theory. Now coming to that, once these sufficient evidences have been gathered, Wegener was very confident of the correctness of his theory. However, one other thing is there on which Wegener has been criticized, and why scientists said that we should not accept or largely discarded theory at that point of time, because Wegener was not able to explain the forces that is responsible for continental drift theory. For example, if you talk about what Wegener is trying to say, Wegener is basically trying to say that such huge land masses, thousands and thousands of, even millions and millions of square kilometer of land masses are there in terms of area, they have been continuously moving in the past 240 million years. But any kind of movement cannot happen by itself. That means if the continental land masses are moving, that means there must be some sort of force that is being applied on these land masses, and this force is what that causes the movement of these land masses. So the problem was that Wegener, he gave the forces. He said that why continents are splitting and moving, he said it is because of two forces. One force is what he refers as a tidal force. Now tidal force is something that is exerted on the earth due to the presence of the sun and moon and its gravitational attraction on the earth. And other force, what he called, is the buoyancy force. So buoyancy force is because of the rotation of the earth, because earth is rotating continuously. However, the equatorial area of earth is moving at or rotating at much more faster speed as compared to the polar areas, and that is why what will happen, the buoyancy force will be higher near the equatorial area, lower near the polar areas. So this disbalance of the force, imbalance of the forces, also because of the gravitational force of sun and moon, these two forces in combined form act together to cause the drifting of the continental land masses. However, this is precisely the reason why scientists discarded his theory, because the forces, the magnitude of these forces is very, very less, and that is why they believe that such a small magnitude, a small scale force cannot cause such a large scale displacement of the continental land mass. So that is the first point of criticism. Second point of criticism was that Wegener was also giving a lot of contradictions in his theory. For example, in the beginning, if you remember what I told you, that Wegener has assumed that the continents are moving over, or Sial is moving over Sima without any sort of resistance. However, in the later part of his theory, he said that Sial is getting some sort of resistance from Sima, and that is why we have the formation of mountain-like structure. So he is contradicting himself. And third point, we have discussed that at that point in time, the prevailing view in geology or geography was contractionist view. That means the scientists believe that the earth is contracting, and that is the reason behind the formation of mountain, not this splitting and drifting of the continental landmass. So mainly because of these reasons, his theory was discarded at that point of time. So anyway, what we can understand in conclusion, that though Wegener's theory was basically discarded at that point of time, it has played a very significant role in understanding the geological structure of the earth as well as the movement of the plates, and that is why we have discussed the plate tectonics largely derives its idea from the continental drift theory of the Wegener. Thus what we can understand is that Wegener's theory was basically way beyond its own time, and that is why it was discarded at that point of time. Now related to that, somewhere in 1950s, almost we can understand 35 to 40 years when after Wegener has given his continental theory, a team of scientists largely led by Harry Hess wanted to explain the sea floor of the earth, what is going on at the ocean bottom, because he believed that if what Wegener is saying or what Wegener has said earlier, if it has to be correct, its evidences must be seen in the ocean bottom, because this is the place which is closest to the Sima layer or closest to the mantle layer of earth today. Thus he tried to observe, understand the ocean bottom, and during this phase a program is largely called as ocean floor mapping program. So we have the beginning of ocean floor mapping program, and also the interest in understanding of the ocean began during the Second World War that happened between 1939 to 1945, and that time, since naval warfare emerged as one of the major dominant form of warfare, there are large scale interest by the countries such as Britain, Germany, France, USA to understand the ocean currents, its structure in more detail. Thus both led by the scientific curiosity as well as the demand of the time, because of the Second World War there is a huge interest, and thus that led to development or beginning of ocean floor mapping program. So when the ocean floor mapping program was being done, 3-4 important observations were made. First observation that was made is that ocean floor is or ocean bottom is not a featureless plain. Earlier there was a prevailing view among the scientific community that ocean bottom must be a featureless plain. It must be a kind of plain area without any significant phenomena that might be happen there. There might not be something of interest that is going on there. But after this ocean floor mapping program, it was understood that it is not a featureless plain, rather it is having lot of diverse features. Now, what are these diverse features? We discussed in the oceanography part, but obviously there are a lot of features such as mountains are there, we have islands are there, we have geos, we have hydrothermal vent, we have chimneys, we have black smokers, white smoker. So, a lot of such variation we see on the ocean bottom. Second point what we can understand is that if you look at the Arthur Holmes convection current theory that we have discussed yesterday when we were talking about the plate tectonics theory, he has talked about two different features. One, he has talked about the mid-oceanic ridge that we also called as MOR. What is MOR? We have discussed yesterday that when two plates move away from each other, a gap is created, and due to this gap, the magma from mantle rises through this gap and deposit itself on the both edges of the plate or on edges of both the plate. So, thus that lead to formation of mid-oceanic ridge. The longest ridge we have discussed yesterday is found in the Atlantic Ocean in a kind of S shape. Third observation that was made, again that was explained by the Arthur Holmes convection current theory and plate tectonics as well, that wherever we have meeting of two plates, what happens if oceanic plate and oceanic plate are converging, if oceanic plate or continental plates are converging, what will happen? A deep, narrow, elongated valley develops which is called as trench. So, both mid-oceanic ridges were also discovered and trench was also discovered during the ocean floor mapping program. So, we have ocean bottom is not a featureless plain, we have the development of mid-oceanic ridges as explained by the Arthur Holmes convection current theory, and we have development of trench because of the subduction of the denser plates below the lighter plate as we have discussed. However, two other very interesting observations were made, and this is what makes a very important point of a part of what we can call as the sea floor spreading theory. So, from these information, let us try to understand that what does sea floor spreading theory states or tells us. So, this theory simply says that what is happening at the ocean bottom, we have a oceanic crust, that is here we have obviously ocean water, and what is happening, the magma is rising from the mantle and it is breaking through the oceanic crust, and then the magma deposit itself on both edges of the oceanic crust forming the mid-oceanic ridge, and on the other side this oceanic crust might be subducting below what we can call as a continental crust. So, this is our continental crust and this is the ocean crust. So, what will happen on this side where the crust is separating apart, we will have formation of a mid-oceanic ridge, and where the oceanic crust is subducting below the continental crust, yesterday we have discussed what will form here, we will have the formation of trench. Thus, what does sea floor spreading theory says? That on the ocean bottom, on one side of the oceanic plate or oceanic crust you will find mid-oceanic ridge, on the other side of the oceanic crust you will find the trenches. Now, interestingly, if you measure the age of the rock of these rocks on the ocean floor, what scientists observed that the age of rock, if I try to write the observation, that the age of the rocks were at the ocean bottom. So, age of rocks at the ocean bottom basically increases from where to here? From mid-oceanic ridge to the trench. That means what they are trying to say is that if you calculate the age of rock at this point which is near to the mid-oceanic ridge, and if you calculate the age at this point which is where? Near the trench, and if you measure the rocks or age of the rocks in the entirety of this crust, what you will find? The age of rock is continuously increasing from ridge to trench. That means the youngest rock will be found where? Youngest rock will be found near the ridge, and oldest rock will be found where? Oldest rock will be found near the trench. So, this is something that also can be explained by sea floor spreading theory of Harry Hess. How we can explain this? that why does the age of rock increases from ridge to trench? Simple logic is there. What is happening here? Magma is continuously erupting and depositing itself near the crust. But at the same time, if you remember yesterday what we have discussed, Arthur Holmes has said that convection current is continuously moving away from this ridge. Thus, it is also moving the plate away continuously from the ridge. Thus, the new rock layer has formed here, but this rock layer will not remain at the same place. It will slightly get displaced away from the ridge. Thus, again as displacement happens, again what happens? A fresh gap will be created, and this gap will again allow fresh magma to erupt, which will again accumulate and deposit after coming in contact with the cool water of the ocean. Thus, we will have formation of fresh layer of rock again. Again what will happen? The convection current will drag it away from the ridge. Again the new rock layer that has formed will slightly get displaced. We will have eruption of the magma again, and thus this process goes on and thus the rock that is forming near the ridge, they keeps on getting displaced away from the ridge due to the horizontal convection current, and new rock layer keep on forming near the ridge. That's what will happen. Obviously, the older rocks are moving away from the ridge and continuously new rock layer is being formed near the mid-oceanic ridge. And thus, that there come the fourth observation or next observation, where what we can see that the age of earth is how much? 4,500 million years. What is the age of the continental crustal rock? Almost same. Even in Bangalore or the Bangalore plateau, Dhara plateau, you can find rocks that is as old as 4 billion years, that is 4,000 million years. But at the ocean bottom, what scientists found that the maximum age that is recorded is about 200 million years for most of the ocean part. Now, why it is so? Why we do not have any rocks that is older than 200 million years? It is because whatever older rocks that has formed before 200 million years ago, what has happened to them? They have reached to the trench area and they have subducted inside the mantle, and thus when the subduction of this plate will happen inside the mantle, this crust will happen inside the mantle, what will happen? The older rocks will start to simply melt, and as older rocks simply start to melt, it will form the fresh magma, and the fresh magma can again rise here near the ridge. Thus, what basically is happening? Near the ridge, you have continuous eruption of new magma, which is forming new layer of rock. Older rocks are continuously getting displaced from the ridge toward the trench. Finally, after about 200 million years, this rock reaches beyond the trench, start to subduct and goes inside the mantle, causing the melting of the crust, and that is what lead to formation of your new magma. And that is why rocks that is older than 200 million years you cannot find on the ocean bottom generally, because they have been destroyed after subducting into the trench area. So, these are the 3-4 important points about the sea floor spreading theory by Harry Hess and his team. Now, about 10 to 12 years later, what happened? Scientists started to imagine, or scientists tried to understand that what is the magnetic properties of the rock at the ocean bottom, what are the changes, or is the magnetic properties of this rock same everywhere on the ocean bottom between the ridge to trench. Thus, somewhere in 1960s, we have what we can call as paleomagnetic study of the ocean bottom. Paleomagnetic study of the ocean bottom. And in this paleomagnetic study of the ocean bottom, what scientists try to understand that how the magnetic polarity of the rocks are changing. For example, if we draw a simple diagram, suppose this is our mid-oceanic ridge here, and this side obviously let us say we have the trench, and both side we have the ocean crust. Now, what happens? Why this ocean crust has formed? How this ocean crust has formed? Simple, because of the eruption of magma near the ridge and the cooling, solidification and deposition of this magma forming into a solid rock. This scientists have found out that in this magma that is coming from the mantle, they have a particle which we can call as magnetite, which is an iron particle. So, magnetite is present in this magma, and thus when the magma started to cool down and solidify, the magnetite particle which is having magnetic characteristics in this magma, they start to align themselves as per the prevailing Earth's magnetic field. That means, if suppose for example today if I draw the Earth's magnetic field, we can draw it like this. The Earth's magnetic field has two poles, north pole and the south pole, which we can refer as NMP, north magnetic pole, SMP, that is the south magnetic pole. Currently, the orientation of the magnetic pole of the Earth is in same direction as that of geographical pole. What does it mean? It means that if I draw the geographical pole of the Earth, so this side we have the geographical north pole, this side we have the geographical south pole. As we know, if I draw a perpendicular line passing through the center of the Earth, the geographical poles of the Earth is tilted at 23.5 degrees, while the magnetic pole of the Earth is tilted at around 11.5 degrees from the perpendicular that we are drawing perpendicular to the Earth's orbital plane around the Sun. So, currently what we can see, despite having different extent of tilt, the north magnetic pole is toward the geographical north pole, the south magnetic pole is toward the geographical south pole. And thus, as per this theory, when the magnetite is cooling and solidifying, these particles will also arrange themselves in the same polarity as that of the Earth's prevailing field. That means, currently whatever rocks are forming near the ridge, if I draw polarity for them, their north magnetic pole will be on this side, south magnetic pole will be on this side. Thus, we can call simply this as a normal magnetic polarity because they are same like the Earth magnetic polarity. However, when scientists try to understand the polarity of the rocks more away from the mid-oceanic ridges, they surprisingly found that it is changing. That means, if I draw another band of rock away from the mid-oceanic ridges, what we see that here the magnetic polarity of the rocks have reversed. That means, now the south magnetic pole is in this direction, that is toward geographical north, and the north magnetic pole of this rock, polarity of this rock is toward the geographical south. Same for this case. Again, after certain distances we have normal polarity, again after certain distances we have the reverse polarity. So, this alternate band of changing magnetic polarity was observed on the rocks of the ocean bottom, and this is something that scientists found very puzzling, that how it is happening or why it is happening, and thus this was explained by two another scientists who are called as Wine and. If their magnetic polarity is reversed, what does it tells us? It tells us that the Earth's magnetic polarity is also not fixed, rather it keep on switching. That means, if today the north magnetic pole is toward geographical north, south magnetic pole is toward geographical south, it does not mean that in the past also it would have remained same. In the past it is possible, or it is the only way possible how we can explain this, is the Earth's south magnetic pole was toward geographical north and Earth's north magnetic pole was toward the geographical south. Thus, from here we have one concept that comes, that is called as polarity reversal or magnetic polarity reversal of the Earth, where in the past we have the south magnetic pole toward the geographical north and north magnetic pole toward the geographical south. And since this is not only a single incidences, this alternate band of rock is found across the Atlantic seaboard, Atlantic ocean bed. What we can understand, that this reversal of the Earth's magnetic polarity happens very frequently, and it has happened many times in the past, and it can happen even in the future as well, whose evidences today obviously we have gathered. That means, this theory came in somewhere in 1950s, 1960s. So, today we have concrete evidences to prove what Wine and Matthews was saying at that particular point of time. And as per the current estimate, scientists believe that the last polarity reversal of Earth has happened somewhere about 45,000 years ago. And again, what is happening currently, if you look at the Earth's magnetic pole, it is slightly moving toward the north. That means, toward the north magnetic pole is moving toward like this, and south magnetic pole is moving like this. And gradually what will happen, they will reach here, then they will reach here. Then it is believed that when they occupy this region, when they reach near the equatorial region, scientists say that Earth at that point in time does not have a single pole, it is having a kind of multiple pole. multiple north poles, multiple south poles we can say will develop there, and again then the polarities start to shift like this, and finally the north magnetic pole will reach here and south magnetic pole will reach here. So that will complete the polarity reversal of the earth. So now if you try to understand all this combined what we have discussed today, that means the development of mid-ocean increases, the eruption of magma at mid-ocean increases, the difference in the age of rock from ridge to trench, the maximum age of rock being recorded is around 200 million years, and also this magnetic polarity and reversal and the study of paleomagnetism. So all this together form what we can call together as a sea floor, part of sea floor spreading theory. And then after sea floor spreading theory, the next stages in the 1970s, early 1970s, we have the plate tectonic theory that was given by Harry Hess, Morgan and J.T. Wilson. So that is all about the continental drift theory as well as the sea floor spreading theory. I hope you understood the basic concept behind all these theories. So thus we have completed all the 4 theories that is required in geomorphology. What do we have? We have plate tectonic theory, we have the Arthur Holmes convection current theory, then we have the Alfred Wegener's continental drift theory, and then we have the Harry Hess and his team that led to development of, along with the help of Pine and Matthews, development of sea floor spreading theory. So that is all about theories part of geomorphology. I hope you understood the concept and liked the video. Thank you very much.